Today's topic is observational study and experiment. Please listen to the paragraph. This course will not require you to plan experiments or obtain data, but you need to understand how experiments were run and data was obtained. When you read articles which have printed the results of some statistical study, so you know what types of conclusion can and cannot be drawn. After all, there isn't much point in gathering sample data and learn how to organize and summarizing and analyzing, interpret and draw a conclusion if the conclusions aren't valid in the end. And there is not much point in reading an article that has invalid results. In many studies, the relationship between two variables are studied in previous math and science classes. You have looked at relations between x and y. In statistics, we call those variables the explanatory and responses variables. So first thing, explanatory and response variables. In a study about whether a variable x affects a variable y, we call x the explanatory variable or the independent variable. We call y the response variable or dependent variable. So I would like to summarize the different vocab in a group of x and y for you right now. So please pause the video right now. So here's a summarized table for you. By looking at x right here, x and y, you learn from before input, output, domain, range, explanatory, response. If you look at all of them right here, they are all alphabetical order. X before y, input before output, domain before range, and explanatory before response. And then you guys have to think about the independent variable. Independent variable is just going to be the one I'm good for myself. I don't need anybody else. Here's your independent variable. And then there's a dependent variable because dependent variable depends on independent variable. So that's the vocab that you need to know how to go back and forth. And we probably sometimes you will hear on this side, you will also get cost and effect. Okay, but I don't want to put that down because that's just something we don't hear it in the vocab of the words, but you should know X is usually the cost and the effect, the cost and the effect on both sides. All right, so moving on. I'm looking at example number 1. So looking at the examples. In research, let's look at the example. In research, we want to know how changing the value of the explanatory value affects the value of the response variable. Number 1, let S equal to student's hands. Let S equals student's hand span and C equals the candy grab. What do you think if we increase S? S in this case is the student's hand span. So I want you guys to pause the video and answer the question number 1 right now. Example number 1, let S equal to student's hand span and C equals candy grab. What do you think if we increase S? If the student's hand span increases, then the student will be able to grab more candy. That's example 1. And please try example 2, 3, and 4, and we'll come back and talk about it. So example number 1 says that let S equal to student's hand span and C equals the candy grab. What do you think if we increase the student's hands or increase S? S in this case is the student's hand span. If the student's hand span increases, then the students will be able to grab more candy. Then the next one, example 2, let H be equal to the hours spent studying for exam and let T equals the test score. What do you think will happen to T as we increase H? If H is hours spent studying for exam. So if the hours spent studying for exam increases, then the test score will also increase. So in this case, I want you guys to also understand S is explanatory variable and the candy grab is going to be responsive variable. Same thing here. There's an explanatory variable and there's the responsive variable. So if is explanatory variable and then is the responsive variable. So this is the same kind of if, then. So number 3, let D equals number of days a student missed class doing the unit. T equals test score on that unit. What do you think will happen if T to T, if we increase D? D is increased. So D is going to be explanatory variable. The number of days students miss in class. So here's the first part. If the number of days a student missed school doing the unit increased, then the test score on that unit will be low. Example number 4. S is the explanatory if the number of pairs of shoes a student own and T equals test score. What do you think will happen to T when we increase S? Well, actually, there's nothing related to each other. So there's nothing really you can even say because it doesn't even make sense. Pairs of shoes and students' test score do not have anything in common, or they are not related. That's a better word. They are not related. So please, they are not related. So that is example number 4. If you understand they don't have any kind of relationship, there's actually nothing you can say. So please just make sure that you write down they are not related to each other. So those are the 4 examples of explanatory variable, and explanatory variable affects the response variable. The next thing is, for instance, to study the effect of alcohol on body temperature, researchers give several different amounts of alcohol to mice. Then they measure the change in each mice's body temperature 15 minutes later. So what is the explanatory variable? Explanatory variable is the cause, and the effect, which is the response variable, they want you to identify both. So please pause the video and try to come up with the answers, and we will discuss it. For this example, for instance, to study the effect of alcohol on body temperature, researchers give several different amounts of alcohol to mice. Then they measure the change in each mouse's body temperature 15 minutes later. So I want you guys to understand which one is the cause, which one is the effect. So to study the effect of alcohol on body temperature. So this is going to be body temperature. Research give several mouse different amount of alcohol. They measure the change in each mouse's body temperature. Okay, so in this case, the explanatory is what happened and then the effect of it. What happened here to the explanatory variable? Explanatory variable is going to be the alcohol that's given to the mice right here, because then they will check if the temperature goes up. So I'm going to write it down, amount of alcohol given to mice. Here's the answer. Explanatory variable, amount of alcohol given to the mice. Responsive variable is change in body temperature in the mice. Next one. When we don't specify the value of either variable before collecting the data, there may or may not be clear explanatory variables, so be careful on that. So the next one we're going to talk about is what is a treatment group, because this explanatory variables also have different kind of category. There's a treatment group. In a study, a collection of individuals who receive a certain treatment or have a certain characteristics of interest. And there's also a control group, a collection of individuals who do not receive any treatment. So treatment group, you do something to it. Control group, you don't do anything to it. Any treatment. So control group is a collection of individuals who do not receive any treatment or do not have the characteristics of any treatment group. So treatment group, you did something to it. Control group, you don't do anything to it. Then the next thing we're going to talk about is how do you bring out the study, because now we talk about different kind of groups that receive different kind of treatment or not having treatment. So then we have how do we check out the data? There's a first type, it's called observational study. Observational study is researchers do not determine which individuals are the treatment group, did something to it, and the control group. Okay, observation, you just sit there and look, and then the researcher do not determine who gets what. Researcher simply collects the data based on what is seen and heard, just observe. Okay, that's called observational study. So there's something that's very important. Okay, in an observational study, we would take a sample of people already using product 1 and another sample of people already using product 2. In the end, we see a significant difference in the amount of weight loss between the two products. We cannot say for sure if the product caused this difference, or maybe there was something about the individual themselves who choose product 1 versus product 2. We did not do anything to control other variables that affect weight loss. This leaves room argument as to why the people use one product lost significantly more weight than those using the other product. Maybe the people who choose product 1 have more weight to lose to begin with, or maybe the people in one group were all in their 20s and the other group had people who were all at least 30 years old, etc. Without trying to control other variables, we don't know what caused people to lose more weight using one product versus the other. We just know they did. So it's very important when you do something like an experiment, you actually set up some parameter. By just looking at you don't know what happened to a certain type of groups. About the design experiment. A design experiment is researcher applies treatments to a group and record the effects. So the researcher knows what kind of treatment it did. Observational study, there's no treatment. We just sit there and watch. So design experiment is researcher apply treatments right here to a group and then records the effect. The researcher determines which individuals are in the treatment group 2 and the control group, often by using random assignments. So the researcher also knows which individual is going to get the treatment, which individual is not going to. That's called the design experiment. All right. So the next part, what kind of design experiment are we talking about? 2 ways to run a design experiment means you know who you're going to give the treatment to, and it's not just sit there and watch. There are special rules for each group. So single blind study. Single blind study is individuals do not know whether they are in the treatment group or the control group. That's a single blind study. We don't know which group you are in. Double blind study is either the individual nor the researcher in touch with the individual know who is in the treatment group and who is in the control group. So single blind is just the individual doesn't know. But the double blind is going to be individual and the researcher doesn't know. So I want to do single is just the individual do not know. But if you have a double, it's individual or the researcher don't know who is getting what. So now we're going to read on different things. So reading on in a design experiment, we would take a group of people wanting to lose weight and we would randomly assign them to one of the two programs. They do not get to choose as they did in the observational study. So since this is a designer, you are going to know they are going to have a treatment to it. In making the assignments, we can make sure that each group has the same balance of gender, age, body fat, bone size, etc. So we are putting parameter on them. We are setting up what are the rules. Here we are attempting to control other variables that we feel is going to affect the amount of the weight that a person will lose. In the end, if we see a significant difference in the amount of the weight loss between the two programs, we can attribute this difference to the weight loss program itself. With a carefully designed experiment, we can establish cause, explanatory, effect, responsive relationship between the variables, not just simply associates between variables as with an observational study. So for example number 5, it says data was gathered at the end of the school year to compare the reading readiness for a group of full-day kindergartners versus a group of half-day kindergartners. The half-day students have significant higher reading readiness scores at the end of the school year than the full day. Half day, sorry, there should be a little date right here. So write a conclusion if this data were the results of an observation study. Now, observation study is we didn't put anybody in any kind of group. It's just something associated with something. So here's what the way I will write it. Association between the reading readiness scores and the length of a school day. There's no discussion about how long or how good or whatever. It's just between the two things. Then if you're going to write this is a conclusion about observation study. Now, if you are going on to talk about what is a conclusion if those data were results of a design experiment. The design experiments based on the things we read before, it says half-day students has a better test scores. So you can say write the conclusion if the data were the results of a designated experiment. If the length of the school day, days is shorter, it will cause the reading readiness scores higher. Or you can say if the length of the school day is longer, it will cause reading readiness score lower. So those are what happened, what you did to the population or the data you are taking a poll, and then after you decided what kind of scores, what you're going to do to the experiment, because they are designated experiments, so therefore there's some sort of design to it. So then you can have a better understanding what happened to the first part, which is the explanatory. No, you can see the variable from explanatory. You can see it from explanatory variable and then cause the response variable. You can see the explanatory and then the response. All right, going on to example number 6. Example 6 says a study of a university students find those who had consumed 250 milliliter cans of Red Bull had an increased thickness of the blood that raised the risk of life-threatening clot as compared to those who did not drink Red Bull. The technical term of the blood thickeningness is coagulability. Okay. So what two questions were asked of the student in this study? So let's go back and take a look at it. The student is asked, university find those who consume Red Bull and what happened to their blood. Okay, because the Red Bull will cause your blood to get thick. Okay, and that cause coagulation, which is coagulability. All right, so let's pause the video and write those things down. That's going to be your explanatory, because that's what happened you do to your body, and the result, there's something happened. So here is what two questions were asked of the students in this study. Do you drink Red Bull? Right here. And then what was the thickness level of their blood? It increased thickness. So in this case, we don't know how much they drink, and that caused the thickness of the blood level. There's two questions there. All right. Now, what is explain why this is an observational study? Well, the reason for that is because it is just going to be researcher did not control anything. Research does not do anything to the students. Research just asked the question. That's why it's observational study. So I'm gonna pause the video and write that down for you. Explain why this is an observational study, because researcher did not control who drinks the Red Bull and who did not. Okay, remember that's observation, just observe, didn't do anything to anybody. Then the next question is, how could you design an experiment be done instead? So in this case, we need to make some group drink it, some group doesn't drink it, or randomly assign students, or anything to do the separation. So what we want to do is I'm going to write down, and then we can read through it. Okay.